Hello there, and welcome to a new episode of Simply Explained. Today we're going to learn about generics, a topic that often seems unfriendly to beginners, but it really shouldn't. In my attempt to simplify it, I'm going to cover three main aspects of generics to provide you with the ability to understand and use generics in your own code after this video. The three topics will be generics in their basic form, generic constraints, and generic variance. If you're interested in learning one of these specific topics, I've created timestamps as usual so you can skip to the relevant part. So let's start. So what are generics? I think it will be helpful to first understand what generics come to solve, right? What is the problem that generics are trying to address? So let's say, for example, we have a method called print data. Okay? It receives some data of type integer and then simply prints this data. Okay? And then when we try to call it, we say print data and we can provide it with an integer, right? And then it will print 4 is printed, right? But what if we want to use the same method and provide it with a string? It will not work, of course, because we can only provide it with an integer. And what if we want to do it with a double, or maybe with a list of integers? We cannot do it, right? Because it expects a certain type of data and we cannot pass other types. So beginners would suggest just taking this method, copying it, and changing the argument type, right? String. And then we're going to be able to provide it with strings. And if you're wondering why it allows us to have two methods with the same name, is because it's a thing called method overloading. It basically says, okay, so you have this similar name for a method, and the only thing that is different is the parameter. So I'm going to use it, and depending on the argument that you're going to provide me, I'm going to decide which one to use, right? So if we're using an integer, it will go to this one, and if we provide it with a string, it will go to this one, right? Because now it can receive strings and integers. And we can do the same thing, right? We can copy it and change it to a double, and then change it to a list of integers, and it will work, right? But this is not an efficient way to work, because the less code we have, the more efficient our code is, right? Less code means less bugs, less potential typos, less maintaining to do. Because this method is pretty simple. It only has one line of code, but if this method had 100 lines of code, it means that all of these ones had 100 lines of code as well. So if we wanted to change something, we had to come here and change it in every one of them, and it's a lot of work. So this is not efficient coding. It's not an efficient way to work. And this is exactly the problem that generics come to solve. With generics, we can simply provide some kind of data type, and this data type is unknown. It's unknown to the compiler, but we can provide it instead of our data type, and then we're going to be able to pass any type that we want, and it will work. So instead of int, we can pass this t, and I'm going to explain to you about what this t means. And in order to enable this generic type, we first need to come before the name of our method and use angle brackets, and then type the name of the generic type. And then you are going to see that it received this special color. And now generics are enabled in this method. So if we come here, we can see that it still works, right? Because we have these methods, but if we delete them, it's still going to work. Because what this T says is basically you are allowed to pass in any type of data you want, and it's fine. I receive every type of data. And the T really stands for type. But don't get confused, you're not obligated to use a T character. You can use whatever character or even name you want. This is just a convention that most developers use, so it will be easier to read others' code. But you don't have to use this T to make it work. You can change it to a different letter and it will work the same way. So here we enable the generic type and we define its name. And then we can use it inside our method. So we can use it as an argument, we can use it inside our code, but here we decide what it will look like. So we decided that it will be the letter M, so then we can refer it over here. If we're not going to specify this part, we're basically not enabling generics in this method, and then the compiler thinks this is a typo, right? It's red, it doesn't know what this M means. But by using these angle brackets and specifying the name, we're basically saying, I want to use a generic type, and this is the name of this type. And then over here, we can basically pass in everything because it expects this generic type. So it doesn't only have to be primitive types, it can also be classes, and it will work, right? Now, of course, we don't have to use one character. We can use full words, full names if we want. As long as we see this color, it means that the generic type is enabled, and then we simply reference this generic type. So we can call it whatever we want. We can give it some kind of name that will help us remember. Generic. And we can see that this color means that it's a generic type, so it's any type of data. Okay? And of course, we don't have to use only one generic type in every method. We can use as many as we want. Okay? So over here, we said that we have one type that is called T and the other type that is called E, and then we can use it for different parameters or maybe in the code. And you see that it will work. Now the reason it screams here is because it expects two parameters, so we can provide whatever we want. We can provide an integer and a string. We can provide a string and a list. We can provide a double and bread. Okay, because these two generic types can be anything. And speaking of anything, what happens behind the scenes is not very different from using the superclass any. Okay? So if you didn't know, any is the father of all the objects we have in Kotlin. If we click on any, we can see that it says the root of the Kotlin class hierarchy. Every Kotlin class has any as a superclass. It means that all objects in Kotlin, primitive types, classes, they all inherit from any. So if we used any, we could do the same thing. Right now it's red because first of all, we need to remove the second parameter, but also we need to remove this generic type and then it will work. Now you must be wondering, so why do we even need generics if we can do this with any? So that's the point, that generics come with even more abilities that won't be available with just using this any class over here. And these are the things that we're going to talk about next. So before we continue to generic constraint, there is one more thing that I want to mention. When we say that we are using a generic type, we also need to make sure that the logic inside of this method will be able to handle a generic type. Right now, we're simply printing the data. Okay, so it converts it to a string and then it prints it. So it doesn't matter what will be the type, it will always convert it to a string. But if we didn't want to print it, but just do something else, we can see that we are not going to be able to run all the usual methods on this data variable. All of the methods that we can run on it can be run only on generic types because the compiler doesn't know what will be the data type. So we cannot run things that are only applicable to integers or strings. We can only do general or generic methods because when we pass in a data type, it has to work every time. So it doesn't matter if we pass an integer or a double or a string, it has to work. So the code inside has to work with all of these different types. That's why we're not seeing any other options over here, and all of these things work on generic types. You can see it over here, right? But if we want, we can return this type, we can print it, we can do other things, but we need to make sure that the method can handle the generic type. So now let's move on to generic constraint. Let's just delete this. So we saw before that we can pass integers and strings and lists into the same method because we're using a generic type and it will work. But in real life, it doesn't really make any sense to pass all of these different types to the same method. Because if we want to print the data, it's logical, but usually we don't want to print it. We want to do other things. So in most cases, it doesn't make any sense to just allow passing any type of data, right? Primitive types, classes, it doesn't make any sense. And as I told you, we have other abilities with generics that we don't have with just using the any class. And one of those things is generic constraint. So by using generic constraint, we can specify what type of data we can pass to be this generic. Okay? And let's see an example. Let's create a method that is called calculate calories. And it does some logic to calculate calories. Okay? And then we don't want to use one specific data type, but we want to use more than one. So we can use generics when we want to use more than one specific type, right? But on the other hand, we also don't want to allow all of the types because calculating calories only applies to certain types of data. So let's enable the use of generics over here. And let's say we receive some kind of item. So now, if we're going to call this method, there is no sense to allow passing of integers. Because how can we calculate calories from an integer? Or maybe a string? Maybe we want to pass strings and then specify some kind of name. But usually we do want to work with classes. So maybe some classes have calories in them and have some property that stores the calories, and then we only want to allow to pass these classes. So we don't want to allow custom classes and then primitive types and doubles and floats. It doesn't make any sense. So with generic constraint, we can narrow the possibilities. We can put some kind of constraint and say, I do want to receive all types, but these types have to qualify. They have to be of a certain category. So we can use it in two main ways. Let's say we have some kind of class that is called product. Then we have a class called food that inherits from product. And let's make it open. Then we have a class called burger that inherits from food. And this one will also be open. Then we have a class called salad that also inherits from food. And maybe we can also create another subclass that is called cheeseburger that inherits from burger. Okay, so this is basic polymorphism, right? This is the superclass in our case, and then food inherits from product, burger inherits from food, cheeseburger inherits from burger. So this is the grandfather, this is the father, the child, the grandchild, okay? There's nothing special about this example over here, but let's say we want to constrain this generic type to only a certain class, okay? So let's think about it. If we want to calculate calories, we need a class that has calories. So here we can put this colon and then specify a name of a class that will be an upper bound. An upper bound means that this is the highest class in the hierarchy that will be able to be qualified in this method, okay, as a T. So in our case, let's think about it. A food can have calories, a burger can have calories, but a product don't always have calories because a product can also be some kind of magazine or a toy or some gadget, right? But food can have calories. And this is where the upper bound comes in. So if we think about it, food is the upper bound in this case because it's the highest class in this hierarchy that is qualified to be passed over here, because we don't want to allow it to receive products, but we do want to allow it to receive foods or any type that inherits from food. So over here we can say food, okay? And it means that now we can only pass food or any class that inherits from food, because all of them will probably have calories. And you can see that now it won't allow us to pass a string. And now it waits for a T, but over here we can see that this T has to be of type food or below. So if we try to pass product, it won't allow us because it says I'm looking for food and a product is not a food. But if we pass a food, it will work. And if we pass a burger, it will work. And if we pass a salad, it will work. And this way we can constrain the types. Another way we can constrain is not by providing some kind of upper bound, but by using interfaces. Okay, so let's say we have other classes that are also maybe foods, but they're drinkable. Beer that inherits from food, and water that is kind of a food. So maybe we don't want to constrain foods, but we want to have some class that will drink, right? Only drink. So we want to allow only drinkable items. And in this case, we can create an interface. And then we can say that beer inherits from drinkable and water, well, not inherits, extends drinkable. So both of these extend drinkable, right? The interface, because both of them are drinkable, not like these ones. And then we can say allow types that are drinkable, only types that are drinkable. So now we won't be able to pass in products, we won't be able to pass in foods or burgers, because even though beer is a food, food is not necessarily drinkable, right? But beer is drinkable, so we are going to be able to pass in beer or water or any other class that extends the drinkable interface. And this is a very useful thing to use because we can just create some kind of interface that will work as a filter to classes that are relevant to our method. And this is the main way we use generic constraints. So the last topic, generic variance, is probably the most difficult to understand and the most confusing one. And if I'm going to be honest, when I tried to learn this topic, I had a really hard time because I read many guides and watched many videos, and people really tried to explain it, but it never clicked because sometimes they just explained what this out and in keywords mean, but it didn't explain what really happens and why do we really use them. So I really did some research, and I hope that I'm going to be able to explain it to you in a better way. And even if not, just remember that this is not something that you run into often, but it's good to know. So the more you understand will be just better for your own benefit. Okay? So what is generic variance? Let me just paste a bunch of code and then we can go over it. Let's get rid of this and let's use the classes that we created earlier. Let's paste another class, which is this box class, and also this bundle of code. So let's try to understand what is going on, and we can start to figure out what is generic variance. So over here we have our classes, right, that inherit one from the other. Then over here we have a class. So up until now we used generic types with methods. But of course we can also use them with classes. And usually they're passed in as a type of a class. So for example, we have this box class, but it receives in these angle brackets, it receives a generic type. So it means that this box will be of some kind of type. So maybe we can say that this box receives some kind of size class, small class, big class, or maybe it receives a type of food. Okay? So this is a box that will fit burgers, or maybe a box that will fit cheeseburgers. So it's sort of a container. The same way we use lists, right? Lists can accept some kind of type inside. It can be integers, strings, other classes. So it's some kind of container. So over here, we receive this type. And when we receive this type, we can also use it as a parameter. We can use it as the type inside of the class. We can return this type. We can add it. We can do things with it. Okay? And over here, we just created a few boxes of different types. So we created a box of product. So it's a box of type product. Then we created a box of food, a box of burgers, and a box of cheeseburger, right? So you are going to know that you're dealing with generic variance when you run into these two keywords. They will usually appear over here before the T, so you're going to meet out or in. And then you will be wondering, what do they mean? And as I said, it's not something that you see often, but it's a good thing to know what it means. So we have the short version and we have a bit of a deeper explanation that is not really necessary for you, and you can absolutely write code and read code without knowing it, but if you want, it's some extra knowledge for yourself. So the simple explanation is that when you see this out keyword over here, it's basically a way to prevent errors, okay? It's a way to actually enable different types of casting without crashing our program. And the same way about in, but the other way around. And of course, I'm going to explain to you. But just know that when you meet these things, if you see the out keyword, it means that we're only going to return this type, whatever it is, we're only going to return it from within this class. So we're not going to be able to add it or consume it or do anything with it. And you can see the red lines over here because we said that we're only going to produce it, right? Only to return it. So over here, we can return it and there's no problem with this part, but we're not going to be able to do all of these things. So if we promise that we're only going to output it, we need to remove all of these methods, otherwise the code won't work. And this is to keep us from making all kinds of exceptions, okay? And we're going to talk about that. The same way with in, but in allows us to receive and consume this item, this type, but not return it. So it's two sides to the coin. Either we want to return all things or we want to receive them. Of course, we can also just not specify these keywords and then everything will work, both returning and receiving, but then we're not going to be able to do different kinds of casting. So let's see. Let's say we have a box of food and then we want to cast and make this box of food into a box of burger. Right now, it won't allow us. And you may be wondering, wait a minute, but a burger is a subtype of food. Why we can't do it? Because we can definitely cast a burger into a food, right? We can make a food become a burger. But a box of burger is not a subtype of box of food, right? Because this is the class, but when it has this generic over here, it becomes a type. So it's a different type. And burger being a subtype of food doesn't mean that a box of burger is a subtype of food. So right now we cannot do this. And the reason it prevents us from doing it is because all kinds of weird things can happen. So for example, right now, if some kind of receiver will expect a food, okay? And then we're going to call this box of food and we're going to get the item, right? The item food inside. But what it will get a burger, right? Because we said that now this box of food is basically a box of burgers. We made this casting. Of course, it won't allow us, but if it worked, it would become a box of burger. So the item inside of this box of food would be a burger. And we can see it over here, right? Expected. And then it's a burger. And this is not a big problem because a burger is a food. But what if we also have some kind of list, right? A list that expects to be a list of food. And then if we say that this list and then expect not box of food, and we go into the list inside of it, right now this list is a list of burgers. So it expects to be a list of food, but it became a list of burgers. And now we're going to see the most problematic part. What if we say box of food add, right? We're using this method. And over here it expects a food. Even though this box of food is now a box of burger, it still expects a food. So we can basically give it a food. any kind of food, a salad. So what happened over here? We added a salad into a box of burgers, right? Into a list of burgers. So now it will be a list of burgers with a salad inside. Someone is not going to be happy with this order. And this is the kind of problems the compiler is trying to prevent. And it says, well, I don't want to allow this to happen, okay? So in order to actually allow this to happen, we can do it by specifying this out keyword. So right now, this will be allowed, but something will be disabled, and this is this add method. So you can see that, as I told you, because we promised to use this out, so we promised to output this type, it means that we cannot receive it. We cannot consume it. And that's why we have to delete this method. And if we delete this method, then there is no way this problem can ever happen, right? So now this will never happen. And over here, we also receive or consume this t. And this is not allowed because we promised that we are only going to return it. So we also need to delete this list, or at least make it a regular list. Okay? And of course, over here, we can also say that it's private, because then we're not going to be able to give it. And it has to be a list, of course. List of what now? Well, I guess we can't really, maybe if we say private. Okay, now, so now we cannot go into the list and add things to it or take things out of it, because we promised that we are only going to return this type. So also this cannot happen. Okay, you understand? This out keyword simply prevents all kinds of weird things to happen. And the in keyword prevents the other way around. Okay, so now we're not going to be able to return the type, but we're going to be able to add it. Or let's just do this. List add X, and of course the list needs to be mutable. Okay, so now this is allowed because we specified the in, and this will not be allowed, right? But the other way around will be allowed. We can now cast a box of burgers and to make it become a box of food. Okay, so this is not allowed because we cannot return anything. So also this is not allowed. And this is the basic reason why we use these keywords. And just so you know, when we don't use any keyword, it's called invariance. If we use the out keyword, it's called covariance. And if we use the in keyword, it's called contravariance. So you can look up these terms. Okay, so if you want to learn about them, you can look them up, but I'm not going to dive into them and their meaning. So I just want to add some commenting over here. Let's take these ones. So we saw this, right? And of course we can say out, or maybe not even specify it. So it's the way it was. So it's basically expects a food. So we need to produce a food. As I told you, when we use the out keyword, we promise to produce the generic type. So we need to produce a food, right? It expects a food. So it doesn't matter if we're going to provide it with a food or any kind of food, right? So when we say out, it means that we're going to allow to cast this item into its subtypes. So when we say out, we can only cast to the subtype of this item, of this class, because any subtype of food will also be a food and will be able to do what food does. So when we produce it, the receiver, right, the receiver will get a food anyway, right? So here we don't know who this receiver is, which part of code expects a food. But if we say out, we basically allow this box of food to be cast and become anything that inherits from food. That's why the equivalent to this in Java is when we see something like this. Okay, so we basically say anything that extends from food. Okay? So anything that extends food is basically equivalent to out. So we say that we can cast a box of food to become a box of food, or a box of burger, or a box of cheeseburger, or even a box of salad. Okay, because all of them are a type of food. But we are not going to be able to cast this box of food into a box of product, because here it expects a type of food, and a product is not a type of food. And because we say that we're going to produce this type, it means that we're going to allow the returning of the type, so someone may receive something that is not a food. Okay? But then if we do want to allow this thing, we need to say in. So now we basically say, okay, you are allowed to cast this box of food to become its supertype. So anything that comes after food, right? A box of product, or maybe even something higher in the ladder. Okay? Because within, we promise that we're only going to consume it. So if we expect a food, and food inherits from product, so food will obviously have calories and product will have calories. So if it still did not click, I prepared a graph, and I hope that after explaining to you this visual graph, all of this will make more sense. Okay, so this is the graph that I've created, and I hope you see it. I'm going to zoom in because some of you are probably using phones, and I know how annoying it is when it's very small. So this is just a way to imagine what is going on behind the scenes. Okay, so when we specify the in keyword, we basically allow the casting of everything that is a burger. For example, the tea is a burger. Like here, the tea was a food, right? But let's say the tea is a burger and we want to cast a food to it. So over here, the tea is a burger and we want to cast a burger to it. Because we say that we only consume, right? In means that we only consume. We need to be able to consume grams and patties, right? Let's say burger has grams and patties. It inherited the grams from the food. And then cheeseburger has grams, patties, and cheese. So if we cast a burger to a burger, then it's fine because we can consume these things. We know how to deal with them. A burger has grams and patties, and we already know how to consume grams and patties. If we provide a food that is a supertype of burger, we can receive these grams, and even though we know how to deal with patties, it's not a problem because it doesn't even have patties. It only has grams, so it's fine because we know how to deal with them. And then anything that will come and be a super type is okay because we will know how to deal with it because we already know how to deal with this lower bound, okay? And the lower bound is this burger. But if we're trying to convert a subtype of burger, let's say a cheeseburger, then it may also have some property that we don't know how to consume, or we cannot allow to add it to all kinds of lists, right? We don't know what to do with cheese, so this is not allowed. So when we use in, we only allow the item itself, the class itself, and any class that is its supertype. And then the other way around with the out, because we promise to return it, right? We promise to produce this type. We need to be able to supply all the things that this class has. So a burger has grams and patties, so we have to be able to supply grams and patties. Like over here, it expected a food, but what it actually expected, it expected the properties or the methods that food has inside. So only subtypes will have all the properties and methods that the type has, because the burger will definitely have grams and patties, and then a cheeseburger will have grams and patties, but maybe other properties, but it doesn't matter because the important thing is that we need to supply the grams and patties. We don't even need to touch the cheese. But what if we want to cast food? Right? What if we want to make a burger become a food? This is not possible because we need to be able to provide grams and patties, but food only has grams. Okay? So if we say out over here, let's delete this. If we say out, and then we try to cast and make this box of burger become a box of food, this is not allowed because we can see it over here. Later, someone will expect a burger, but it will get a food, okay, if this is allowed. So if it will get a food, maybe some properties will be missing, and then it won't work. And this is just a way for you to understand a bit what happens behind the scenes. And of course, as I told you, this is going very deep into how things work, and you really don't need to know this. It's not like you need to know it to make your code work, but it's good to know how these things work behind the scenes. So I hope that it answers your questions. Of course, there's a lot more to generics, but these are the main things you need to know. And even, for example, generic variance is something pretty rare to run into. So I think I covered most of the things you're going to deal with in this topic of generics. So of course, if you have other questions or you still don't understand, you can comment and I'm going to try to answer. And also if you have other ideas for things that I can talk about or maybe create videos about, then you are also welcome to write it in the comment section. So I hope you learned something new and see you next time.